Hey guys, welcome back to Understanding Mathematics, and today we're going to be mastering the product and quotient rule. Now, I'm not going to be going into too much detail on what product and quotient rule are, because conceptually they're very easy. It's just a formula that gives you the derivative. Hopefully you have that much down, but you came here because there's a couple of really tough examples on your homework, or you're nervous for your test, or whatever that may be. And in some cases, it's better to not even use the product and quotient rule. Sometimes you can do some manipulation and get around them. And I'm going to show you some instances where it's better to try to avoid it and go around it with algebra. Product and quotient rule aren't very difficult by any means. What's difficult is the algebra, and if you have a hard time adding and subtracting exponents and multiplying them, then you get into some trouble. So hopefully I can give you some examples where it shows you how to deal with that tough algebra. So let's just jump right in. We're going to solve the derivative with and without the product rule. And we're given f of x equal to 3x to the fourth minus 5. That quantity is times x squared minus 4x plus 2. Okay, well, we know the product rule. Let's just work this out. So it's the derivative of the first times the second as it is. Okay. So derivative of this is just 12x cubed. Minus 5, derivative of 5 is 0 because it's a constant. Okay, and that's just going to be multiplied the quantity that I underlined in green. Second part is not, you don't take the derivative of it yet, you just leave it as is. Plus 2. Okay, so we're halfway there. Now we have to add the second part. So now, this blue part that we underlined, we took the derivative of that already. So now we just leave it as is. Three x fourth minus 5. Okay, and now we're going to multiply that by this green quantity, but we're going to take the derivative of it. So 2x minus 4, which is very easy derivatives. It's nothing difficult here. And so what's going to get you on these problems is your algebra. If your algebra is weak and if you don't know all these distributive properties, you're going to get messed up. And so hopefully we can shed some light on how to deal with them. And so this problem is no longer calculus. This is just algebra. So all you do is distribute out these exponents. And so if you don't know how to multiply out these exponents, I'm going to show you how right now. And that's probably the hardest part of this problem. 12x cubed times x squared. But when you multiply exponents, you add the numbers, you add the actual exponents. So you get 12x to the fifth because you add them. And then, it's simple distributive property, so 12x cubed times negative 4x, negative 48. And then you just add it again, 3 plus 1. Okay, well, that's a 4. And then 12x cubed plus 2, 24x cubed. Okay, so we're done with that, with this part. Now we do the second. Oops, I meant to do highlight. Now we do this part over here. Okay, so 3x to the fourth times 2x, that's just going to be 6x to the fifth. 3x to the fourth times negative 4. It's negative 12x to the fourth. Negative 5 times 2x is going to be minus 10x. And then negative 5 times negative 4, positive 20. So that was all stuff you did in like 8th or 9th grade. That's just all algebra. This is like a really hard distributive problem. But if you have that down, this is really easy. So now we have to add like terms. So we have a positive x to the fifth and then a positive 6x fifth over here. So 12 plus 6 is just going to be 18x to the fifth. Okay, so then I like to scratch them out just so I don't have to deal with them again. I don't have to look at them anymore. I know that they're done. Now let's do x to the fourth. You have a negative 48 x to the fourth, and then a negative 12 over here. So add those together, you're going to get negative 60 x to the fourth. Okay. Now scratch that out. That's done. Now, are there any x cubes? Yes. Plus 12 x cubed. Scratch that out. No x squared minus 10x plus 20. And that's your derivative right there. That's the answer. Now, let's say you're having an exam and you finish a little bit early, and you should check your answers. Instead of doing the product rule all over again, I recommend solving this derivative without the product rule. And sometimes in your homeworks and exams, they might even ask you solve with and without the product rule. So that's next. We're going to do without the product rule. So how do you do that? Well, in this last problem, we took the derivative and then we combined, and then we did distribution. Well, in this one, we're going to do distribution first, and then we'll do the derivatives. Okay, well, let's get in. This is going to be a lot of writing, so get ready. So 3x to the fourth times x squared. That's just, remember, you add your exponents. Okay, so just like that, minus 12 the fifth, and then just plus 6x to the fourth. This should be really easy. This is all review. And so now we do the negative 5 times x squared. Negative 5 times x squared plus 20x minus 10. Okay. I'm just going to double check myself really fast just because this is it's so easy to make a mistake here. 4th minus 5x squared plus 20x minus 10. Okay, we look good. So now you have this is your whole term. Now what we do is we take the derivative of each piece individually. So this is no longer a product rule question. We turned it into just a power rule question. So you have all these different derivatives that you can take. 6 different ones. Just do one at a time. Oops, that's like that. My bad. Alright, so 6 different derivatives. And that should give us this answer here, this highlighted one down here. And if they're the same, we know we did our product rule right. If they're different, we messed up somewhere. The derivative of this is 18 x5. I'm assuming you know the power rule already. And this one down here is negative 60 x to the fourth. And usually when I would do these, back when I was learning calculus, I would check, just right away to make sure my terms make sense. I was like, okay, 18x to the fifth. Okay, cool, 18x to the fifth here. Negative 60x to the fourth. Wow, I have that here. And so that's kind of how you know you're on the right path. And it's really reassuring when you're doing a problem you're not so sure about. This is 24x to the third. This is negative 10x. This one, the derivative of 20x is just 20. And derivative of a constant is 0. So that's our derivative here. And if we look, that's going to be exactly the same. That's going to be exactly the same as this one here. So that's how we know our product rule was correct. And it's really up to you which one you'd rather do. Would you rather do the product rule, do this formula? Would you rather distribute everything out and take the individual power rules? It really comes down to preference. Obviously, it's good to know both because you'll probably be asked to do both, and you should really know both. But at the end of the day, it's really up to preference. I mean, if you look at this one, the without product rule, it's a lot less work. I did more work here on the product rule, so I think I would prefer without the product rule. That's just me. There's some cases where you need it. Another good example of this is using the quotient rule. and very similar to the product rule, as you know. Okay, so let's just get into this one. Derivative of f of x, 3x squared plus 4x all over the square root of x. Okay, well, I'm assuming you know the quotient rule. Let's do the derivative of the top first, and that's just going to be 6x plus 4. Oh, I messed that up. Let's erase that. Plus 4 times the square root of x. Now this is where it's different from the product rule, because in the product rule you add, but quotient rule you subtract. Subtract, and here we have the top the same. Don't change the top here, just put it in. Plus 4x, and then times the derivative of the bottom. Well, what's that going to end up being? That is the same as x to the 1/2. And so when you write it like this, that's when you can do your power rule. I'm sure you learned that. Just I want to cover all bases just to be sure. Okay, so that becomes 1/2 x to the negative 1/2. All right, and then don't forget to square the denominator. That's I forgot that a lot. Square root of x squared. So the bottom is just going to be x, but I wanted to write all that down. So then you can multiply everything out and try to find common numbers and add them, and then you can get less numbers on top. So square root of x times 6x. Now this is a good example of when your algebra is weak and you don't know how to add your exponents when you're multiplying them. Add or multiply your exponents. This is a really good instance where that happens. So what's the square root of x times 6x? Well, think of x as x to the 1, right? And so you add exponents when you multiply their bases. So 1 plus 1/2, and that's just 6x to the 3/2. Hopefully that makes sense. 1 plus 1/2, you can change 1 to 2 over 2. 2 over 2 plus 1 over 2 is 3 over 2. And then 4 is easy. It's just 4x 1/2. Now we do the other half. Minus 3/2. Okay, so now what's x squared times 1/2 x to the negative 1/2? So let's just look at the exponents now. So we have 2 minus 1/2. Well, let's change 2 into 4/2. 4/2 minus 1/2. That's 3/2. And that is the hardest part of quotient rule. It's combining these exponents. Product rule and quotient rule, both of them. But in my experience, it comes out a lot more in quotient rule. Quotient rule is where you get these ugly square roots and ugly fractions in the exponents, and you really need to learn how to deal with them, and this is a good example of dealing with it. And then plus 4 times 1/2 is just 2. X, this is a 1, x to the 1. So 1 minus 1/2 is just 1/2. Okay, that's all over x. Now we can reduce our terms on top, because if you notice we need to combine like terms, and so we have x to the 3/2, x to the 3/2 here, x to the 1/2, x to the 1/2 here. So we can combine those and just get it down to 2 terms on top. So 6x minus 3/2, that's going to be 9/2. Change it into 12/2, 12/2 minus 3/2, 9/2. And the exponent stays the same, 3/2. And then 4x plus 2x, it's going to be, oh well, actually I made a mistake here, actually. I would have to factor in this negative. So this is negative and this is also negative, so that's not, that just goes to show how easy it is to make algebraic mistakes. in these problems. So the negative should get factored to these whole terms here. So we would get 4x to the 1/2 minus 2x to the 1/2. So then we just add plus 2x to the 1/2. Yeah, you have to be really careful with your algebra. It's so easy to make a mistake. Even someone who's been doing this forever will make a mistake. And then you divide by your denominator x. So this is a lot cleaner and easier to deal with. Okay. And so what's 9/2? X to the 3/2 divided by x. Well, when you divide, you subtract the exponent. So we can think of this as an x to the 1. So 3/2 minus 1. That's just going to be 1/2. So now we have 9/2 square root of x plus 2x 1/2. 1/2 minus 1 is negative 1/2 plus 2. You can just write it like that. So it's important to know that this first one here is multiplied in the numerator, and this one over here is multiplied in the denominator. That's important to know, and that's our answer for the quotient rule. But how do we know if that's correct? Well, we'll repeat what we did, and we'll just do it without the quotient rule. And so if you noticed, I wrote the problem here a little bit differently. Here it's one denominator, it's all divided by square root of x, but here I divided them both, and I made it into a sum. I divided them both by the square root of x separately, and then I'm going to add them together. You can only do this when you have one term on the denominator. If our denominator was square root of x plus 1, you can no longer do it. You have to keep it. That's when you have to use the quotient rule. And my advice is don't use the quotient rule if you don't have to. If you can avoid it using these little fraction tricks, absolutely do that. Okay, so let's get into solving this. And this is a lot more algebra heavy than the quotient rule itself. So what's 3x squared divided by x to the 1/2? And in other words, 2 minus 1/2. What's 2 minus 1/2? 3/2. 3x to the 3/2. And then over here, 4x divided by square root of x, that's the same as 1 minus 1/2. So we'll have 4x to the 1/2. I hope that makes sense. Basically, think of this as a 1. Think of this as a 1/2 exponent. So you subtract the exponents and you divide. So 1 minus 1/2 will leave you with another 1/2. And so this is what we have left. There's no squaring the denominator. There's no subtracting. It's so much simpler when you can avoid the quotient rule. And so now we have two separate terms. And so now what we do with our separate terms is we just take the derivative of them separately. 3x to the 3/2 power, take that derivative, get 9/2 square root of x. Because we'll get left with x to the 1/2. We just convert that into square root. Plus 4 times 1/2, that's going to be 2. And then you're left with an x to the negative 1/2, or square root in the denominator. And so this is our answer here. This is what we found. Does this match up with this one? Oh, I meant to highlight. And yeah, it looks like it does. And so that's a really good way to double check your work in product and quotient rule. It's also a good way to solve these problems if you don't want to deal with the quotient rule. And I absolutely recommend avoiding the quotient rule if you can. Look how much work I did here, and look how much I did here. I mean, neither of them are like a tremendous amount, obviously, but this one is like at least half of it. Without the quotient rule is so much better. Product rule, I think that one is more up to you, but the quotient rule ones, it's just avoid the quotient rule if you can, because the quotient rule is just so messy. Okay guys, that's going to wrap up this video of understanding mathematics. I hope you enjoyed, and I hope this helped you out a lot. Good luck on all your exams. See you next time.